right, check it out. I have been looking for one of these for a long time, and I might have scored a diamond in the rough here. I don't quite know yet. There we go. Oh, wow. Yeah, baby. Well, that never, ever, ever would have worked. Let's jump into walking around. I'll show you what this thing is. I'll show you what it can do. Now, this is a machine that I've been needing for quite some time. This is a pressure washer, but not just any pressure washer. This pressure washer will boil the water to 250 degrees Fahrenheit and give you hot water or steam. They're also known as steam cleaners. So this is an MiTM. It is powered by a Honda GX 390, which is an amazing motor. Absolutely great. They run awesome. And then it's diesel fired. The actual burner is this top piece here. I literally know nothing about it, but this thing has, according to this, if it's right, 76.8 hours. And that's not 768 because that says tenths. So your last number is tenths, plus you can barely read a dot. Either it's brand new or it had an issue really early on. I really don't know. I've been looking for one of these for a long time at a price that I could afford. Now, you can buy these usually in really crappy condition. They're $800 to $1,000, and that's usually something's broken or it's not working correctly and they just don't want to mess with it. For this machine, I got a top-handled steel chainsaw and another air compressor, one of those hot dog style, with a GX 160 Honda on it, all for 120 bucks. The story is they were cleaning out a container, and at the back of the container was this, and they were just going to throw it in a dumpster, and the guy I got it from said, no, I'll take it. He took it home, got it running on starting fluid, and then he sold it to me. He had this thing listed for 75 bucks. I couldn't say yes fast enough. This is probably a $5,000 to $7,000 machine, brand new. MiTM doesn't make this exact one anymore. I really don't care. It doesn't matter to me if I got an old model or an old style. What matters is I'm about 75 bucks into this thing so far. So the good is it might be low hours. 3,500 PSI. Engine is not locked up. It's rusty. It needs some work. Cool thing about this, it has an electric start, has the key, start. There's your battery tray right there, and it's got oil in it. I'll show you. We're sitting at an angle a little bit, but yep, see there's oil. Doesn't look too bad, a little bit golden. The other really good thing is that this is an Inovi Riveri, however the heck you say that, pump. Rebuild kits for this are readily available. This is a Beckett burner, and it runs on the diesel fuel. Parts for that are really readily available, and parts for the Honda are absolutely readily available. Biggest thing that I think is going to be the biggest issue with this thing is whether or not this burner is going to work. When you look down in there, and I can't show you really well right now, but I'm pretty sure I see a mouse nest. Coils, they're basically a whole bunch of water coils all the way through this, and those are what the water runs through while it's being heated. If those are bad, has a leak, or has the mouse pee has caused, holes in it, that could be the most expensive part of getting this thing up and running, or up and useful. I think we can get it running for sure. The water comes in through that hole there. There's a little thing there, comes into the pump, and then this line goes out to the quick connect for the wand and the hose. We've got a disconnected line off the bottom of the boiler, another small line disconnected. This line here is just dangling. Over here, we're missing something there. That's probably a blow-off valve. Maybe missing something there, and that little just might be just like the blow-off where it goes. I kind of think that the boiler has been bypassed. Because, okay, here's a plug. So that's been capped. Almost makes me wonder if this went like here, down off the pump. I definitely think that the boiler itself has been bypassed, which is not a great sign absolute worst case scenario, we have maybe a decent motor for something else. I really want one of these things. This baby's roll around on 4 wheels. These two have air in them, these two don't. I want to see if it'll take any air in these two because I hate things that don't roll correctly. I've been wanting one of these for a long time because when you start working on a lot of this heavy equipment that I own, the dirt, grease, grime, it's so much harder to get off with just a cold water pressure washer. Sweet. Got like water dripping out of this handle. Yummy. Oh, cool. Is that a... Okay, so that would be for basically locking the wheel. So you would pull this and it would put pressure against the wheel, and that would be like a brake. And then come to find out, these front ones, they must be rubber filled or something because that valve stem is broken. The other valve stem on this wheel is missing, but they are definitely not going flat. So, and I don't think there's a tube in them either. So they must have filled them with foam or rubber or something. These two took air, surprisingly. I didn't do anything. I didn't clean the beads. I just got it up off of the ground, let it suspend, and then kind of messed with it until it took air. Just touching this thing for 2 seconds, this is what I'm getting covered in. Okay, so this is like a wand, little wand rest, something like that. And then this is probably for the hose, pressure washer hose to hang, but it got bent over time. Not sure what that's for. There's where you put the diesel in. Here's how you connect the hose to the actual unit. And then right through there, right here, is where you hook up the water. And then here you control 30 degrees all the way up to 250 degrees. And then here's your burner on, off. I don't know. We'll figure it out. Let's get this thing cleaned up. Start tearing into this thing. These are gonna bite me. Oh, it bit me. One more, I think. Yep. There we go. All right, check it out. So, this is a Honda GX390. It is a beast of a motor. And other than us pressure washing it, I know that this is free. It feels like it has compression. Yep. We're missing the air cleaner. This is your throttle, which does move. Let's see if the governor... Yep, that's free. That's good. And then we got an electric start. I wonder how good the tank is. I am betting the tank is going to be kind of nasty. That's not a good sign. Oh, wow. It's like perfect. Look at that. There's like no rust at all. Even that little screen on the intake or on the pickup tube. Wow. I seriously thought there was going to be a ton of junk in there. Well, maybe this thing was put away right. I don't know. We're going to find out. So my biggest concern with this machine is why why was the hot water boiler bypassed? So water comes in right here, goes into the pump, and it should then go to the boiler, up through the boiler, and then come out and go out this one right here, which is where you hook up your hose and your wand and be able to be pressure washed. What this one looks to be is straight up set up to do cold. So water comes into the pressure washer, comes right out of the pressure washer, and goes right to the wand. So what are we gonna find when we look in that thing? Does the burner have issues? Right, so right here we've got the oil level for the pump, and it should be right in the middle. It is over full. I don't think it looks murky. It looks pretty much the way oil should be. Because if it did look murky, that might mean that there's water in it. Looks pretty good, actually. On the stick, it's like right there. I would assume the oil level on this is between here and here. So the sight glass says a little over, but on this stick, it actually looks right. Right off the bat, I notice, obviously, we're going to need whatever lines it takes to hook up the hot water. But I also saw, see this line? This wire here is broken. It looks like this one's about to break. This line is cut, or this wire is cut. Only some electrical tape going up into this thing. Let's throw a battery on it and see if it even spins. So here's the thing. When you're working with a pressure washer, you got to be careful. Because if you run, say we're trying to diagnose whether this engine runs. Well, that pump is going to be spinning. Now, I could take the time and I could disengage it, but I really don't want to do that. So we don't want to run this very long at all, assuming it runs. If we get it running, then great, awesome. Maybe what we'll do is we'll hook up water to it and see what happens. But you will burn up a pump and the seals and the O-rings in a pump fairly quickly if you don't have water going through that pump. So let's just see if it'll even fire. If we can get it firing, get it running at all, then maybe we'll roll it outside and we'll put water in it and see what happens. I say we just see the viability of the motor, and then we'll see if the pump actually creates pressure. If it does, then we'll jump into the boiler and the burner and see what happens there. If you guys have never used a powerful jump pack, these JNC or the jump and carry ones are amazing. I like the 12 and 24 volt ones because it gives me the option. I have a lot of machines that are 24 volts, but even on 12 volts, it is massively powerful. These are heavy. The nice thing is that there's no buttons, there's no electronics, there's nothing that could go wrong. Battery power directly where you need it. And the only button on it is right here. And so once I plug in, say we'll go 12 volt, if I push this button here, it'll show just under maybe 14 volts or so. And then if I do it over to the 24, it shows over 25 volts. And so all that button does is a gauge to tell you how the batteries are doing. The way you turn it on and off is you unplug this. So I guarantee that this is a 12 volt machine. Try and keep that positive down here out of the way. Throw the negative up here. What do you think the chances it just fires? Well, probably low because it probably doesn't have any fuel. What are the chances it even cranks? Here we go. Oh. All right, one more time. Yeah, baby. That crank's strong. Sweet. I almost think we dribble a little gas in there and see what happens. I have not taken the carb off or anything, so I'm not sure what these wires are for. We're going to have to tear into that. I don't want to get it started and then not be able to turn it off. Absolute worst case scenario, we just yank this spark plug out, and that ought to kill it. All right, I got a little mix. This is high octane, ethanol free mixed gas. And we're just gonna dribble a little bit down there, see what happens. Wow, I was not expecting it to start so quick. All right, well, we have strong running machines, so I kind of really believe this might only have 78 hours on it. All right, so real quick, I want to dive into these wires. Looks like, so we've got this wire here. I pulled it apart, the connection. The connection actually looks really good. It's clean. There's enough here that I should be able to get one of these little solder tube things, and then we'll also do some heat shrink wrap on that as well. These ones so this one's about to break and this one's broken. I pulled apart the connection. They are very corroded. So I think what we're going to do on these is we're just going to eliminate the quick connect. Cut it here. And there. And then on this end, we're going to cut it here. And here. And then we'll shrink those two together as well. So I should be able to get all three of those connections made better. I do want to check these two because I haven't opened up those two yet. So that's how you use these. So essentially, you put the two wires together, and right in the middle there's solder in there, and so it heat shrinks around, and then that solder melts the two wires together in the middle of it. And then I take another piece of heat shrink tubing and I put it over the top. But I want to let that cool because I've had issues where if I do it right away, it starts to heat this edge, and then I can't get it all the way up. Problem I don't have in my personal life. I always like to shrink the ends so that it can't slide anywhere. And then I work my way to the middle. All right, we'll let those cool. I think this one's going to be too big for this wire. I don't use these tiny ones very often, but I think we're in a situation where we need to. So I've done a lot of wiring like this, where you have these connections, and then you put shrink tubing over the top. And this is different. This is not normal shrink tubing. It has an adhesive inside, so they call it a dual layer, but it also it shrinks down 3 to 1. Really, really good stuff. All right, lastly, let's check these. Ooh, okay, that looks clean. Nice. How about this one? Beautiful. Looks good too. I cleaned up these two pieces, got all the corrosion off of them. Let's do the same to the gas cap. So, got a 50-50 here. I took this Scotch-Brite, cleaned that side of it with Scotch-Brite, this side not. It's amazing what a little bit of elbow grease will do. Ding, 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 ding. Now that absolutely doesn't mean anything. This is the important side. I'm going to go through that, get a little cleaner. All right, that's about as clean as I'm going to get it. Put this back on here. So this machine came with this. This is what I would assume is the wand. It is missing the trigger end. It's broken here. So this is probably where the actual trigger end was. And then over here, there's probably a quick connect for the actual tips. So this is all I got. But a while back, I was cleaning out a building, and I got these. These are 3 dual wand hot water pressure washer wands. These things are rated to go to 160 Celsius or 320 Fahrenheit. So this machine will make up to 250 degrees Fahrenheit. So this is perfect. So I've got that as an option. And if we come back to this one, this is my pressure washer parts. for like the guns and the tips and stuff. So we're gonna dig through this. I don't know what I've got. That's like one of those suctions for putting chemical in it. Yeah, detergent hose, there's another one. Some washers. There's some quick connects and some tips. And then over the years, if I find like a wand is bad or broken, I'll hang on to the pieces of it. So I've got 3 trigger mechanisms. There's some more quick connects. And this is like a adjusting valve for how much water pressure. Same, that's a different quick connect. All right, so let's see what we can find. I bet you one of these will thread right onto the end of that. And then these are the quick connects for the end to be able to have the different tips. Let's see. This one looks like it needs a male end, so this one's male. So if I clean up those threads, I'll bet you I can thread that right in there. That one male. Oh, that's female. That one's female. This one is rated to, same thing, 160 degrees Celsius, 320 Fahrenheit, 5,000 bar, 5,000 PSI, 350 bar. So this is probably a good wand too. Let's see if it's not clogged. It is dirty. It also did not come with any hose. The same place I got these 3 wands, I got actually a couple of hose reels, and one of them I took this hose off it. The other hose reel that I got at the same time has the hose still on it, but this is hot water pressure washer hose, which, if you don't know, when you use a hot water pressure washer, you want a certain rating, because if you are putting hot water through just your traditional hose, there's a very good chance you're going to melt it and cause the issues. Same with the wands. The wands are very specific as well. So that's another thing we should look here. Okay, that one, this gun here is up to 300 degrees Fahrenheit. Same with that one. And this one's rated to 300 degrees Fahrenheit. So all 3 of these could work for making that one work. All right, well, since we have it running, it almost makes me want to just put gas in the tank and hook up water to it and just see what happens. Probably ought to check oil. I think I did the oil, but let's just make sure. Yeah, we got oil. It doesn't even look very old. Well, I guess one side of the stick does. It's like black on one side of the stick and totally golden on the other. Oh, because there's like sludge down there. Oh, wow. Oh, there's like, yeah, chunks. Interesting. But for now, let's grab the hose. Let's grab one of these and go outside. All right, we're going to put some same gas, high octane, ethanol free. We're not going to fill it, but that should be enough. We've got the water hooked up, got the pressure washer hose attached with the wand. Let's turn on some water. Our pump is leaking. That burner still has power to it. The pump is pouring out water there in a couple spots. All right, so all I've got is the water on. It's leaking out of each one of these heads right there. And then this line, this little bypass line, is leaking right here, and a couple spots actually. So it looks like we're not going to go any further than, well, actually, let's just go ahead and start it. Might as well. Let's see, let's turn the fuel on. Let's go ahead and crank it. It is definitely not building pressure right. Let's see here. So it is definitely killing it. Something in the pump is causing the engine to die. All right, I went ahead and popped off the caps for all of these check valves. So there are 3 inlet check valves and 3 outlet check valves, and they are all identical. They look like this, and each one has an O-ring that goes in there like that. And then the check valve basically is a little spring-loaded cap that lets pressure go one way. And I've basically tried them all. They all work the way they should. What I'm thinking I'm going to do is replace all 6 O-rings. And then the only other thing I did find is that, you know how we saw water spraying out of this? Well, this O-ring was bad. Same with that one there, and this one down here. These 2 are still good. So if I can find 6 of the right O-ring here, I'm going to go ahead and place all of them, and we'll see if we get it back. I don't know how good the actual pistons are. To get into that, we've got to take off these 8 bolts. I'm not going to do that right now. Let's just go ahead and replace O-rings here, and we'll see if that helps us. If not, we'll have to get deeper into the pump. One really cool thing I didn't notice until just now is it has a clear pre-filter right here that has O-rings on either side that allows you to see all the gunk and buildup that might be coming in, which is kind of cool. I did replace this little inlet screen. I put a brand new one in there. Okay, I found a suitable replacement. I've got all 5 of those in. All right, let's give that a shot. All right, so what do we know? We know that the carburetor's dirty because it was surging and it wouldn't run on full open. So we got to take the carburetor off. I know that I think this middle one sealed up. I think these bottom 3 sealed up, but these 2 didn't. And it could be all 3 on the top are leaking. For sure, I need to get a bypass, or I need to get a rebuild kit for this pump. I need to get this bypass hose is absolutely leaking. Other than that, probably going to want to clean out this little glass filter. I really should put the hose on it and try it the right way. Definitely better than it was because it wasn't squirting water everywhere. So, yeah. I wonder, well, I guess we're not running it long enough to have it gone past 76.8. All right. I think I know what's going on here. I am pretty sure the pump is fine, but it keeps blowing out those O-rings on the back there because it has no unloader valve hooked up. What I think happened is maybe this boiler doesn't work right. And wherever it was before, they probably thought to themselves, okay, well, we don't really need it to be a hot water pressure washer, but we could use it as a cold water pressure washer. So let's just bypass all this stuff, make no water go through there because I'm betting it leaks. So they're thinking completely bypass everything, go right from the pump to the outlet. And so when you're pulling the trigger, you're getting pressure correctly. You're getting everything. But what happens, you let go of the trigger, it kills the engine. When it kills the engine, it's doing that because the pump builds up so much pressure so fast that it just dies. It just stops this engine from running completely. I'm not going to do anything more with trying to start it at this moment because I want to figure out all the lines, get the water flowing right, and then we can better diagnose what's going on. So far, I am way ahead. If nothing else works, I have a $75 GX390 13-horse Honda engine that I could pull off of this, junk the rest, and then have, you know, be money ahead. Not what I want to do. I want to get this thing running. I do think we can figure it out. The next step here, we're gonna drain the oil real quick. Let's pop this oil since we did run it a little bit. So it's got this little line. I've got the whole machine on a wood block over there to kind of tilt this way. So we are gonna probably just, ooh, there's a little water in there. Yeah, a little water came out. Well, even better that we're doing it. So it's gonna take it a minute to drain. Let's just let it go. All right, so Maisie and I have been basically studying this machine, trying to figure out the way that the water should flow. So water flows right in that inlet there, goes to this little T, basically has this little bypass line here, that loop one, that one leaks on us. And then right here, right there, that's a plug. So this should not be there. That should be a nipple for this. And then this line should not go to the outlet. This line should come up here. This line should probably be a really short one, a little whip that goes from here to there. So my guess is that they probably had an internal leak inside the actual burner coil. And so instead of trying to figure out if they want to replace it or spend the money on it, they just said, hey, let's just make it a cold water pressure washer. So they had this line made up because it actually has one fitting size here and a different one over there. And they figure, hey, we'll loop it. Well, that never, ever, ever would have worked because what was happening is the second, if I had the trigger pulled on the actual pressure washer gun, it would spray. The second I let go, all the pressure built up, and then this thing basically had nowhere to bypass the pressure because this is an unloader valve right there. Relieves pressure when you let go of the trigger. So when you let go of that trigger, that pressure that the pump is creating has to go somewhere. And so it's either going to go out the nozzle when you pull the trigger, or what was happening here is it was literally building up pressure inside here, blowing this O-ring, this O-ring, this O-ring, and a couple on the bottom, and then that pressure still built up too much, and it basically kills the engine. That's why it was killing it. The engine's not the issue. What the issue is that it's not plumbed right. It's not set up right. So my bet is whoever the heck worked on this literally just did it to try and make it a cold water pressure washer, and they didn't get a chance to actually operate it after the failure of whatever happened in here. So we're gonna tear that open, but I wanna start with getting this set up the way it should be. So the fuel system is pretty much untouched other than they basically just undid that one and took it off. It gets fuel is that essentially there's a line here that goes up to this fuel water separator, and then there's a fuel pump right here. That fuel pump pulls fuel in through this water separator into the burner. It burns the fluid, and that's how it creates heat to heat the water. And then there's a second line that goes and returns back to the tank for unused fuel in the actual burner section. Let's see what we can do about getting this set up right. My guess is when we hook water to it, somehow water is going to leak in this burner section. All right, let's go see if we can find a hose barb with that thread. Here's where I've got a lot of my brass fittings. This is hose barbs. Many of these are used. Many of them are just new or whatever, but let's see what we can find. That one looks right. It's really kind of mangled up though. I think I need a bigger barbed end. That one might do it as well. Take that one with us. There's an even bigger one. That bigger one might be the... All right, let's take a few of these over there and we'll get it tried out. All right, here's our options. This is the biggest one I've got. Let's just see if it'll thread in there. Yep, that will work. And then, yeah, it fits actually pretty dang nice on that hose too. So, well, great. Now I gotta get it out. Well, it fits really well. I'm gonna pull that out and we'll get it sealed up, put back in. Got one thing set back to the way it should be. So this end is not a swivel end, so I need to take the other side off first. All right, there's our fuel line hooked up. So now I've got two things hooked back up. I had some extra, basically, hydraulic hose that's just not got any ends crimped on. So what I'm going to do, take it into the local shop and we're going to get some ends crimped on. So I'm basically converting it to JIC on both ends. Both ends are going to have this fitting. And so to do that, I had to remove an adapter here, and then I changed this by actually added that same adapter here, which allowed me to get JIC on both ends. And then over here, it was already JIC on both ends. And then for this little bypass hose, it basically is like 1/8 inch pipe to this tiny little JIC. So what I found an 1/8 inch pipe to JIC. So then what I'm going to do is I'm going to convert both ends of this to a JIC fitting, because I have this 1/4 inch line that'll be perfect for it. These big ones are rated to, I think it's 5,000, yeah, 5,000 PSI, 345 bar, or -50 Fahrenheit to 260 degrees Fahrenheit. This thing does up to 250 degrees Fahrenheit, so I'm going to have to ask them if that's going to be enough temperature variation in regards to handling the temperature. This little line here is rated to 6,500 PSI and the same temperature, -50 to 260 degrees Fahrenheit. So it's way over what this thing says here. This thing says 1/4 inch, 300 PSI air oil combo hose. So I could probably throw some hose clamps on that thing and maybe make it work, but since I've got this line and I'm already going in, we're just going to get 2 lines made out of the 1/2 inch stuff and 1 line made out of this 1/4 inch stuff, unless they tell me that these 1/2 inch lines are not going to be able to handle the heat, and then we need to buy a different line that's rated for a higher temperature. I'll have to ask them that, but this is way overkill for the little line that we need. Let's head over to that shop now and we'll get some hoses made. There we go. One more line. So there are two overflow valves, essentially blow-off valves. One right here, that essentially keeps hot water from backfeeding into the pump. So if it gets to a certain degree, it will blow and it'll basically push that hot water out this here. And the other one's right here. Essentially, a certain pressure will also bypass here to avoid any blowback at the person operating the machine. I don't know if they ever had a line like this on it, but just like a coolant overflow tube, I'm just going to add a little piece of rubber tubing to just so it doesn't spray straight at somebody or spray down and splatter. This particular one, it kind of comes out at a 90, and so we're going to take this and just shove that on there and stick it straight down like that. Maybe I'll throw a zip tie around that, kind of keep it. Yeah, probably put it right here, and I'll throw a zip tie right through that hole. And then if it is having an issue, it'll just dump straight onto the ground rather than accidentally spray somebody. So that's kind of the thought. Other than that, we are buttoned up back here. I kind of tucked up the fuel line, got it ran a little bit better. All of the electrical can kind of swing back over here where it goes. All right, as of right now, I got all the oil drained out, and this is kind of what it looks like. There's a little bit of water in it. It's milky. And then it's got this swirl in it, but it doesn't look metallic. Either way, it's not great. So, glad we dropped that. The plan is, I'm going to run one of these just junk oils I got from somewhere. I've got a Quaker State, who knows what that is. The plan is, I want to run some cheap oil in it, get it hot, clean it up inside, get everything broken free and broken loose, and then we'll drain the oil again and check it and see how it looks. So let's just get some oil in it, because now that we have everything hooked up for the pressure washer, I want to hook some water to it and have it ready in case we decide to start it. So if we have a leak in the coil up here, I'm probably not going to start it because I just don't want to create a pressurized leak and then make it worse. But before we go taking it outside and starting it up again or checking the water, I want to get this top cover off. I'm betting this is kale wool, which is like fabric material used a lot of times with like forges. Really, really good insulation. I can finally show you what I thought was a mouse nest. So you see all that? All that is, honestly, it's just insulation. And it's basically this stuff that's kind of gotten wet and fallen off of, the edge here, down in there. I'll grab a vacuum and just suck all that out. All right, now you can see down in there, got all that cleaned out. Looks much better in there than it did before. At least now, once we start it, we'll be able to see water if it starts pooling up down there. I'm pretty sure this is supposed to be where you hang the hose, the line. Let's see if we can bend it back out. That should be good. Good enough. All right, I got the hose attached to it, attached to the actual wand, and I've got the water hooked up. So let's just start by turning the water on. See what happens. Oh yeah, see that? There's definitely water in those coils that are leaking. I knew it. I knew that there was going to be a leak down there, and that's why they bypassed it. It is leaking pretty heavy down in there. Where it's leaking, I do not know. Let's just go ahead and turn this off. All right, well, that's all I needed to know. All right, let's blow some water out of it. Got a little air hose here. All I hear is air coming out right there. The plan is going to be to take the coil out, and to do that, I believe I can do, there's a fitting right here I can take off, and fitting over there I can take off. Then I should be able to just lift the coil straight up and out. Only thing I don't know is whether or not the burner, actually, I know it goes through the hole, but I don't know if the coil stops here. This blanket, this insulation blanket, goes all the way around it. This piece, these two ends, and the whole bottom should just stay put. I shouldn't have to take those out based on the parts diagrams. There is no service manual that I've found, so we're just gonna go with a little bit of intuition here. What you got, Maisie? Yeah, hi, pretty girl. What do you think? You think this thing's just junk? Should we fix it? Should we fix it, Maisie? I think we do that, don't we? Let's give it a shot. So I think I'm going to try and weld it. When we get down there, let's find out if it's corroded a hole or if water was left in this thing and it froze and cracked. If it froze and cracked, I'm less worried about it because it's more, you know, there's going to be more meat in the metal there. But if it corroded and poked a hole through, then we might just be chasing holes all over. So start by getting this thing out. Sweet. Get loosened. Oh, the whole pipe loosened up in the coil. Just to be sure this is not going to be in the way, I'm going to take off this burner. There's our burner. I think that's loose. You've got this like high heat caulk around the edges, but I'm pretty sure this coil is loose. I just got to find a way to grab it. This must be for lifting it. Okay, let's see if I can find a lifting eye. There's a nut right here in the middle. Leave it. Found a lifting eye. And then what I'm going to do, I'm going to use the car lift. Grab a strap real quick. trying to reuse this insulation blanket. So here's the burner end. It does look like there was a little bit of a mouse nest right here. So the worry is the corrosion right at the bottom where the water sits. Let me get a vacuum and clean that out. All right, so I've been inspecting this coil, and honestly, it looks like it's in really good shape. The wall thickness, I believe the pipe is that thick. You see that little piece of pipe sitting there? They stuck that pipe in as a little bit of a spacer to hold the pipe away from here and here so it would have the right angle coming out of the coil. So they stuck that piece of pipe there, they welded it right here, and then they left it. My guess is, and correct me if I'm wrong, but that's probably the same exact wall thickness as this entire coil is. They also used little pieces of it down here for spacers. These have rusted significantly more because they were for the bottom. Same over here to there. So, seeing as how thick that wall is, that's a great sign. Now, I found 2 leaks. One, I can probably show you. You see that crack right there? And I don't know if you can tell or not, but it's bulged out. And so I believe that what happened was water was left in this thing. It was either left in a shop that wasn't heated, or it was left outside and it cracked. The water froze, it expanded, and it cracked. And I thought, okay, cool, that's kind of accessible without having to tear this whole thing apart. And I can probably weld that where it's at. The other thing I found, and I don't know if I can show it to you, is, see right there? There's a crack right on that pipe, which also is pretty accessible. I just need to cut out this plate here. And so this plate is probably, I mean, the burner fires right at that plate, so it's probably just like a heat diffusion plate. So it essentially, the burner blows right at it, and it just deflects the heat sideways so that it hits the coils a little bit better. To fix this spot, I'm really gonna have to kind of V that out, grind into it, try and get all the water out of the coil. But let's start by getting this plate cut open so that we can see the leak behind it. I almost wonder if I just try and fold it back. Because if the leak's just, if the break is just right there, then maybe I don't have to do all the cutting. Let's try that first. Dang, that's one heck of a break. Wow. That is significantly larger than I thought. And that's definitely due to water expanding. And yeah, you can see that wall thickness now, how thick that wall is. All right, I need to get this plate a little bit more out of the way, so let's do some cutting. Redundancy. Dang, that pipe split big time in there. Wow. This is gonna be more complicated. We might have to take off the back cover too. There's a plate in the back. It's a round circle. Might have to cut that off. I weakened these welds, just a little cut. I'm gonna try and pound that thing out. So this is for sure what I wanted to see, but it's worse than I wanted to see. So I wanted to see, like, you know, a crack like we have right there. And I found one. We also have this entire split. So there's another split right here. And then there's this big peel back. So this whole chunk just peeled this way. So that is indicative of something that froze, expanded, and basically destroyed that pipe. So that means there's enough metal to weld there. At least I hope. We're gonna try it. This thing, to buy one new one of these is about $1,300 before shipping. So if I can fix this, great. So now the plan is gonna be, I have to get this coil hot. The reason I want to get it hot and warm is to get good penetration and whatever. I don't want water vapor in the pipe. So we need to make this hot. Got to get it warm so that all of the water evaporates out, blow air through it, and try and get it as good as we can. All right, I scored up that top chunk. And there's our piece. Yeah, there's a good chunk of pipe still in that thing. This one is so catastrophic. Okay, so that actually kind of makes sense. That is the smallest coil, and it's the most inner coil on this side. There's another one on the other side. Water would sit right there. I could see sitting right at the bottom of that, and just expanding, expanding, expanding. Can't go any further. Pop. Blew that out. And then same with this coil here, right down there. Just pop. It fits really nice. Just a heck of a lot longer of a weld. All right, I got this coil outside. You can see that's our big hole. And then right down here, I basically ground out and I drilled holes on either side of the cracks. Drilled a hole here, drilled a hole right there. The rest of this is just cracked off, so it's less of an issue worrying about that. And then I've blown it out with air. And now we're gonna use a propane torch. We're gonna heat this thing up, try and boil off all of the water, get it all clean so that we can get the best chance of actually welding this thing. All right, this thing is still super hot. Man, this is hot. Kind of want to weld it while it's hot, but it's hot. So I got that whole piece laid in there, got it welded in, and I just went over it and covered the whole thing to eliminate any additional cracks. That one I'm less positive about. Yeah, let's give it a test. I've plugged this end of the coil and this end here, and I've got this basically air attachment. So I can take this cap off here. It's like an air chuck on a tire. I can basically put air into the coil. We can see the PSI that it's gonna be here. Honestly, this thing is rated to be able to handle 3,500 PSI from that pressure washer. So if it can handle that kind of water pressure, it can handle 150 PSI of air. We're gonna start maybe 100, and then we're gonna spray the whole thing down with soapy water and see if we have any leaks. I do not know for sure if these are the only two spots it froze, but I'm pretty confident there's no additional leaks. But let's find out. All right, let's put a little air in there. Oh yeah, there's definitely another leak. All right, let's figure out where. It's somewhere like right in there. Let's throw a little soapy water on that weld. Yep, my weld is leaking too. Watch that weld. Okay, it's not a new leak. It's leaking out of that one and blowing that way. Okay, that's fine. I'm gonna grind some of this out. A little bit more of a leak at the bottom of that one, and a little bit leak on that one. So, all right, so I'm having trouble getting this to actually seal up with just air pressure. And so we've got the one leak there and then the one in there. I know if I spent a ton more time, I could get this sealed up and I could probably make it usable. The only thing is for how long. So I think for right now, I'm going to set this aside. I'm going to look into what it would cost to actually buy a new coil. I think they're about $1,500, maybe a little bit less, but there's just like, I think lowest one I saw was like 900 something, but it didn't say how much shipping. But then there was one that was 1,200 plus $250 shipping or something to that effect. So let's set this aside. Let's turn our attention back to the machine. We need to figure out exactly if there's any other issues. All right, so next up, I want to mess with the actual burner itself and make sure it operates the way it should. I know the fan does come on, but it's got this little electrical panel here. Let's open it up and try and figure out, if it'll actually burn, does it ignite, and can we get fuel to flow from the tank to the burner itself. We should be able to bypass a bunch of the safeties or the sensors and put 12 volts directly to it, and we'll test a couple pieces. All right, so this is a Beckett burner. These are used a lot on hot water pressure washers, also on like oil burners in houses. And so you get fuel, it comes in here through this filter into here. It then has an electronic shutoff solenoid. So this basically is a on-off switch for fuel. And then once this is on, it comes through this line and goes into the burning chamber all the way in where the nozzle's at, and then that's where it gets sprayed. And then in the actual burner section, that's when it burns and creates the heat. This, we have the igniter side of it. So this little piece here, we'll open it up and I'll show you. It basically it's basically a transformer, essentially. It creates about 10,000 volts. And so if you're ever going to work on one of these, do it safely. I'll show you how I usually do it and how I mess with them. But they're not rocket science. It is not something that the average guy couldn't do. It's also very dangerous, so if you think that you can't do it, then you shouldn't. But let's jump into the little electric panel here. So I need to get a new one of these because it's cracked. So like this corner's broken off, this corner's broken off. It's only being held on by these two. And there's a seal that kind of keeps water out of this, and I'd really like to have that seal. So, all right, so in here we've got wires for the switch for the burner, the hour meter, and the actual thermostat. I know what we could do is we can basically pull the wires that go to the actual burner or the igniter, which is this red wire here and this black wire here. We can pull those out, put 12 volts to them, and we can see if we get any voltage on the igniter. It's got these two little tabs. You can loosen. It should be under tension, spring pressure. We fold this back. So right here, these are the two essentially leads coming out of the transformer itself. And voltage will jump from this one to this one, and it does it by basically contacting this electrode and this electrode here. So if we want to just test that, we could take these two wires off and check. And actually, now that I realize the 2 wires that I pulled off over there are actually for the blower. And so the blower is connected in here to the fan. The fan is actually what, blows air this way. But it also has a shaft that goes over to this the fuel pump. And so when the blower is running, fuel pump is running. But it's only able to put fuel through once this electric solenoid gets energized and essentially opens. So we need to check and see if that opens. We need to check if the blower works, and we need to make sure we've got spark. And after that, we can put some fuel in, and we'll see if we can actually get it to fire without having to be completely connected to everything. So, all right, got the leads connected to the blower. Let's see if it works. All right, you can see it spinning right in there. I can feel the air going that way. Now, change this over, and we'll put this blue wire is actually the one that's positive, and the black wire is our ground. So this is where you have to be careful. You want to get an insulated screwdriver. Definitely making spark. For now, we know that works. All right, I'm going to hook these back up where they were. Just discharge anything. I don't think it should be like a capacitor, but I've got the fuel solenoid, basically the wire disconnected, so I've got 2 alligator clips, one on each of those terminals in there. And I'm going to put 12 volts to it, and we're going to hear if we hear a click. We're listening for click, 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 click. There we go. Yep. It is at least doing something. Definitely don't know for sure if it's fully moving it where it should, but we'll check that later. I did also find that this fitting here, not sure why, was really loose. So that is fuel coming through the pump into the burner. So I'm going to tighten that up before we go any further. All right, I want to drain whatever diesel's left in here. So it's got this little valve here on the bottom. There we go. Looks like that's all we're going to get out of it. Crazy Maisie. Ready? Come on, Maisie. Good girl. Come here. Oh. Yeah. 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 Come here. Good girl. Yeah. Aww. Ready? Come here, Maisie. Good girl, Crazy Maisie. Yeah, you're a good girl. Maisie is an absolutely awesome shop dog. All she wants to do is be right there with you. If I go outside, she'll just follow me. She'll run around maybe 100 feet away. Never runs too far. Always wants to play. But she lets me get some work done. So, let's get back to this. What we need to do, I need to check the actual burner to make sure that it actually does burner things. So, we've got some of it jumpered, and we're going to run that down to a battery. We're going to put some diesel fuel in it and make sure that we can get it to actually create fire. So right out of here, we should see fire. So if you could recommend a good repair kit to convert these to from the crappy style that has the no no vent. I bought some kits at like Tractor Supply, and I don't know if you can tell, but we're leaking right out of where the actual spout goes in. And so it's kind of frustrating. I'm dripping, making a mess. Now the nice thing is I was able to put this vent in it, and vents are great because it allows air to go in, so you're not trying to suck air in where the fuel goes out. But I want to find a good spout that I can screw onto one of these without having to do any modifying. And I've got a bunch of these gas cans. I'm just about sick and tired of making a mess. All right, so we're right about there. That should give us enough to run it. All right, I got it all wired up, and we are gonna see if we get fuel. We're only getting the fan. We're not getting any fuel, and we're not getting the igniter. Here's our igniter. I forgot this wire. All right, we should have the fan, we should have the shutoff solenoid, and we should have the igniter. So we should hear some clicking. Yep. That's our spark right there. That's what ignites the fuel. All right, so the shutoff solenoid clicks on, and I heard it come off. The fan turns on, and we get spark. The igniter works. The only thing we're not getting is fuel. Now, it could be having a hard time pulling fuel and priming everything because the fuel filter itself is empty. There is a bleed valve on the bottom of this fuel inlet there, and so we can bleed the air out there. I am halfway tempted to just pull this off and just look at the actual pump and see if it's got issues. And if it has issues, we'll go there. It's 4 Allen heads, and we'll have that off. So there's a little bit of gumminess in that cover there. Looks like we've got a screen, which does not look too bad. A little bit of residue right there on the bottom. Let's see what this thing does. I can hear that solenoid clicking. It looks like I have to maybe take these off to get into the actual pump portion. There's that little cover off. Doesn't look terrible in there. It's a gear pump. As this gear turns inside of this one, it compresses the fuel and pushes it up through the line. Okay, so it's pulling fuel actually up here on top, coming in, and that lower line there, that's the bypass return line. There's another inlet on the bottom that is plugged. I'm gonna bump it real quick. I just want to see if those gears turn. I'm pretty sure they do, but I wondered if that was a bad idea. So this little gear spins inside of this. Huh, interesting. But having this in there fixtures it. All right, so I think I got it all primed up. Right here is a bleeder. So we're gonna turn it on, see if we get fuel out of that. There we go. Make a little bit of a mess here, but all right. Now we're gonna give it the ignition. Well, that seems like a lot. Huh. We're doing something. So I think we're getting way too much fuel. There is a way to adjust it right here, because that's just excessive. Nice. So, we've got some new parts for the hot water pressure washer. Big shout out to MiTM. They are the makers of the machine, and they reached out and basically said they wanted to help me get this bad boy up and running. And the awesome thing is that they still make and stock every single part. I'm pretty sure this machine is from like 2006, 2011, I can't remember, but it is not new. And every single part that I needed, they were able to find and get for me. So, including the all-important coil. Apparently this coil for hot water units is the same one they use in tons and tons of different machines. Definitely got lucky there. I feel truly thankful and blessed. Let's jump right into the box and see what we've got. So we've got some of the pump seals and pump rebuild kit parts. That is the new thermostat. Oh, sweet. The new insulation pieces. Some more rebuild parts for the pump. Apparently, I didn't know this. Hot water pressure washer tips, the actual tip is extremely important because if it wears out and starts putting out too much, it actually puts additional wear and tear on the actual pump to the degree that it's actually bad for it. So they sent me a new set of tips. Didn't know that was such a big deal. Some more O-rings. There's an unloader valve. Water line. Gas cap, a filter, another water line, or is that a hot water? Oh, that's the actual pressure washer hose. Here's two more of the water lines. We got some decals here. And this is a new manifold for the pump. Apparently, when you deadhead a pressure washer pump, it actually can stretch the threads to the point that they will not ever seal up again. And so we think that may have happened with this machine, the way that they tried to bypass all the safeties and make it a cold water pressure washer. And so it was leaking out of all three of these. So essentially, we're going to basically put a brand new one on it. So there's that. And then we have our all-important coil. All right, here's the parts that we've got. We've got the full rebuild kit for the actual pump. We've got some new hoses for it, a new unloader valve, a filter, some parts for the actual wand to be able to get one of these pressure washer wands. We're probably going to rebuild or make a couple out of everything we have here. Set up for different things. What I want to start with is we're going to jump into that pump, but before that, I kind of scraped out this inside here, and I'd like to hit this with some high heat black paint because I really don't want this, getting any worse. We're not doing a full restoration of this whole thing, but the second that I put the insulation in and the new coil, it's going to be a lot of work to have to get everything torn apart to get in here to put some paint on it. So if we throw some in now, we'll be ahead of the game. And so let's start with that. All right, there we go. Got that looking a lot nicer. Basically just coated it. I kind of went a little further than I wanted to. I wasn't going to do the outsides, but I went ahead and did the outsides, kind of did that plate. Really need to do this whole blower mechanism for the actual burner, but I don't want to lose the decal. I might peel that off and then re-glue it back on, but again, we're not restoring this. We're getting this thing looking nicer and operational. That's all I really want. Way better in here. I'm gonna let this dry, and then we're gonna get the new insulation in, and we'll put the coil in. But for now, let's start rebuilding that. All right, let's get this little bypass line off. So I think what we're gonna do, I'm gonna leave it on here. I have a full rebuild kit to do the oil seals in the pump that are way back here. We're going to avoid that. We're going to try and basically just replace the head and all of its components. So I was talking to the guys at MiTM, and they said because of the situation with this thing, somebody ran it without the bypass valve. They're worried that the actual threads for these caps for the valves have stretched and will no longer seal. So that's why we're replacing the actual head itself. Normally you wouldn't do that. Most times probably fine. But because of this unique situation with regards to somebody messing stuff up, we're going a little further. If I can get away with not having to replace the actual oil seals, I want to do that, and I'll hang on to that kit for later in case I need it. But the other issue we've got is there's a wire that comes out of this and goes into the electrical box. I'd have to cut some stuff in the box and redo some electrical. I really don't want to do that. So what I think I'm going to do is we'll take the head off, and then I can spin the head off of this fitting, and then that way I can leave that electrical alone. There we go. There we go. There's our head. We're going to take this apart, get some pieces out of it. We're going to replace these pistons here. And there is quite a bit of junk build up in here. We'll try and get as much of that out as we can. There's our piston. There's 3 of them. It's like a, I don't know, a composite or some sort of porcelain. And then there's a little like ring, brass ring back here. And there's an O-ring on the end of each of these. O-ring and a backer ring. A backup ring. So rubber O-ring or seal at the bottom of there. I'm going to try and clean out the inside of those bores a little bit better before I go getting that ring out. Because right now, that's what's going to seal the dust from going further into the pump. So I looked in there. It's not an O-ring. It's an actual oil seal. And it seals the oil into the actual, housing away from the water side here. So one of two schools of thought is there's a side cover here, and then there's a cover on the other side. We could get into it and rebuild the whole pump, because I do have everything to do that. I have seen no signs of oil on this side at all. So I think at this point right now, I just want to wait. I want to clean up what I can from over here, rebuild the head, put it back together. Later on down the road, if I get a leak or something, we can dive into that later. I've got a ton of other things I have to do on this machine, and I don't want to open up a can of worms by doing that. So let's focus on this side. Get these threads all cleaned up. All right, here's our new pistons. They all look great. And actually now, there's a little bit of wear in that one. Not a lot, actually. Either way, we've got them. Got those. Just make sure we got all the parts. 3 new nuts. 3 new copper washers. 3 new brass slingers or spacers. 3 O-rings and 3 backer rings. Let's go get these put on. Start with these little rings. All right, our backer rings. An O-ring. Piston. Just broke one of the backer rings. I'm going to reuse an old one. All it does is push against that O-ring, keeping it sturdy and strong so it doesn't blow out. And the old ones are in good enough shape. Now we've got 3 copper crush washers, sealing washer, and then 3 new nuts. And actually, we're going to put some Loctite on these. All right, I need to go get some Loctite to put those on, but for right now, we're going to keep working on the head. So all these valves are identical, and we've got new ones for all 6. We got to reach down in there. Well, we don't have to actually have to do that. There's O-rings down in there, O-rings down in there. We're going to leave them alone. We do need these plugs. So that's going to go up there. Alright, so for this new one, you got an O-ring. You drop that down all the way to the bottom. And then the valve basically drops straight down like that. And some of these valves, they probably would have been okay, but they're kind of rusty. And I just like to have a good set in there. Make sure you get an O-ring in each one. The other thing we have is new O-rings for the caps. We'll get all these torqued down later. All right, now we're gonna try and get these plugs out. There's one way is to use these where you spread it and you basically try and pull. I tried it, I kind of marred the inside a little bit, so I had to file it. I don't want to do that, so we're gonna use a puller with a slide hammer on. So this will go down in there and it'll basically catch on the edges. And then it spreads out, just to give it a little bit of a snug. Just like that. Boom. Just like that, and we didn't damage it all. So the reason we did that is we need these. These pieces I don't have replacements for, and I don't need replacements for them. These are totally fine. We'll clean these up, get all the debris out of them, put them right back to use. We have replacements for the O-rings. There's O-rings on the outside edge of this. And then the packings. And then I already removed the old seals that go inside of this. Those are these guys right here. Alright, got them all cleaned up. As good as I'm going to get them. So these seals, push them down in there. There's a little O-ring, and you want the flat part facing up. And there's an O-ring on the outside. Just like this. Then what we do is we stick this gray ring down. That seal goes down. And then this piece just pushes straight down on top. Stick the seal in, flat face up, just kind of work it around like so. An O-ring goes on the outside of it. This gray ring goes down with the rounded side up. Same with this seal. And then this piece goes in. And that thing is ready to go. Alright, I got some Loctite. Alright, I'm going to get all those torqued. I'm going to get these caps torqued. And we'll start reassembling the rest. Get this torqued to 218 inch-pounds. There we got our new filter here. Some thread sealant on this guy. There we go, that's where you hook up your hose. Amazing. Good. Ruh-roh. I'm gonna have to take this off. There's our new coil. So we have to add a pipe here and a pipe here. All right, that's some new insulation. Forgot these little insulation strips here. So the inside of this fuel cap, when I opened it originally, it just fell apart. This is like all little pieces of the inside. Yeah. So, and that essentially is the seal slash the venting mechanism to be able to vent the tank. So it's missing that seal. So we've got a brand new one here with everything in it. I have these 3 untested pressure washer guns, and they've all got the dual wand, but I thought it'd be nice to have this one set up as well. And over the years, I've kind of just scavenged parts off stuff. I've got these 3, and so I think I'm gonna go with this one. It'll thread right on there. And then we've got a quick connect for the tips. That'll thread right in here. And then I've got the end that goes into the actual hose here. So I'm gonna get that thing put together. The other thing I need, ooh, ouch. The other thing I need to do is set up this hose. Got a brand new hose. So I've got to put the male and female quick connects on that. I went with, so this thing has stainless steel covers, right? And yet it had all kinds of just general steel hardware that caused rust all over it. And so I found dug through my stash and found some big bolts for actually holding the top cover on. I found a bunch of small ones for all of the front covers. For instance, these 4 here that hold this panel in, they were all just a, regular steel, and they were all rusty. But it looks so much nicer. And I went on this panel here, I went and I took steel wool and was able to get all the rust off of this edge here. We're going to be taking off that decal, and hopefully that one. I haven't gotten the new one of that one in yet. Same over here. We're going to take all these decals off. I'm going to try and get as much of that stainless cleaned up and looking nicer as I can. This is what the steel bolts do. They leave that residue. It's not too big of a deal. It just looks terrible. And I get it. It's a cost thing. It's so much cheaper to buy and produce machines with just your regular steel bolts than stainless. But for me, I've got it. I would rather put it together and have stainless in it. If we need to dive into the actual motor, as far as I do have a carburetor that I bought for a GX 240. This is a GX 390. And so I am about 90% positive they're the same carburetor. The other thing I found, I dug through, I've got another, I think it is a GX 240, but I have this air cleaner set up. This base goes on here, other way. Just like this. Air filter that is good enough for now. So I'll get that on, and then the cover essentially goes like that once I get that run down. And there's another wing nut for the top. So that'll get that kind of buttoned up. I threw a battery in it. It's not connected, but it fits in the tray, and it's holding the charge. So that'll be awesome. I am going to try and hit some of this with some flat black paint, just to kind of dress it up, make it look a little bit nicer. We're not restoring this, like I said, but, the thing about a machine, any machine, is the nicer it looks, the better it is. The nicer it looks, the more valuable it is. The nicer it looks, the more you actually want to continue to take care of it. And this is a machine that I really need, because all of the old junk that I bring home is caked in old oil and grease and all kinds of stuff. And a hot water pressure washer is one of the absolute best ways to cut through all that. And so I'm totally pumped to have this. Absolutely amazing working with MiTM. Their group is extremely knowledgeable. I called them. I was basically telling them my issues and telling them what the guy did as far as who trying to make this a cold water pressure washer by bypassing the coil. And they knew it was bad, whoever did that. And they're the ones that basically were ones that told me, you probably need a new manifold. I never would have even thought of that. I just would have kept throwing O-rings at it and wondered why it leaked. But if you have issues with pressure washers or you need one, definitely reach out to those guys. Great group of people. They've got every part for all the old ones too if you need help. So let's work on getting this wand put together. We'll get that hose put together, and then we're going to do a little cleanup and some decal removal. So that only gets the decal off. There's still the adhesive left. I tried Goo Gone, had no success. Goof Off is a much stronger adhesive remover or tack remover of some sort. So what you do, basically just spray it and keep spraying it. Don't really want it all over this cap. Actually, let's put this bag on it. So pretty much like that. And then we'll take a little oil, steel wool, and that looks a million times better. So I'm going to remove that decal and that far one and the one up there for the actual tips. It's going to look so much nicer. All right, we got this wonderful bend here. Let's see if we can make that look a little nicer. A little bit nicer here. It's looking so much better. It's never going to be perfect, but it'll be perfect for who it's for. Good enough for me. Rattle can Dan. Couple nuts for those. I think I need a nut for that one. The rest of these have the nuts built in, but man, that thing is looking so good. See all those scratch marks kind of in the stainless there? Those are basically from my thumb when we were getting all that adhesive off, and I don't like the way it looks. So what I did on this top, and I'm not quite done yet, but you take red Scotch-Brite and you run it in one direction to realign the grains of the stainless steel. You don't want to go back and forth like scrubbing. You go one direction, and you keep moving so you don't get like lawnmower stripes in it. And so I want to try and clean this up, make it look a little nicer. And then what we're going to do is we're going to take gray over the top of it, which should be basically a finer grit than the red. And we're not going for a show pony here. We are trying to make it look nicer. I'm going to do the same with this one. There's, you know, some fading and where we had the kind of the corrosion and runs, and it should take a lot of that out and really bring back the brightness and the shine in this. Going to the point that we might as well make it look a little nicer. Plus, the stainless will make it look really good. This crease here doesn't look great. You know, you can tell that it was bent. There's like a line here, a line there, some here. I'm not a body guy. If you have any good ideas on how to actually get that out without being a body guy and making that look nicer, I don't have a roller for actual sheet metal. I would be curious to know how to kind of make that look better. If you have any ideas, definitely let me know. But for now, let's get that Scotch-Brite and let's start brightening this up. Definitely starting to clean up. I can still see them. All right, I have the whole decal kit, well, the safety decal kit anyway, and yeah, like risk of fire, risk of fire, risk of fire, risk of injury, don't stick your hand in a pulley. I don't know, I understand why companies need to put this stuff on their machines, but I don't, and so really, the only thing I want out of all these is this operation sticker, and of course, it ended up on a fold right where the top layer of the decal kind of messed up, but whatever, we'll deal with that in a minute. But I'm going to cut this out because, again, I don't need Spanish and French. I just need English, and that's all that I read. So let's make it simple. All right, we'll put that one on it. So originally that big operation sticker was right here. It says this would have been in that area with all the other stuff. But I don't really want to mess that up. I have this 3500 PSI. I'm either going to put it here, or I think probably right there. And then we're going to put the decal for MiTM right here. And then we might just leave this really clean. I'm going to stick this just right here on this air cleaner. Perfect spot. You pretty much have to come right here to start the machine anyway. And, you know, obviously no matter if you electric start it or pull start it, I think right here would be a good spot for that. All right, I'm still waiting on some decals. Like I need this replacement decal, then we'll replace this cover. I need the MiTM decal. And I'm not sure if they're going to find that stripe that used to be in that area or not. If they do find it, we'll put it on. But man, this thing looks good. I am really happy with how it turned out. All right, so what I made here was a way to get the water out of the machine. So you plug this in where you'd have your hose. You can hook up an air line to it, and it'll blow all the water out. At least that's the goal. Because the big thing with these hot water pressure washer is it has this really long coil that if any water gets left in there, it ends up freezing, destroying it. And they're expensive. It's not a ridiculous amount of work to replace one, but they're expensive, and I don't want to do it again. Hopefully, we'll have to give it a shot. This will work. A normal pressure washer, it would work. We'll have to give this one a shot and see if it works, but we've got the tool. all the years that I've owned this truck, my service truck, I've never washed it. Never once. Not since the day I got it. So, I think it'd be a perfect opportunity to try out this hot water pressure washer. We'll get all that, well, everything off it. Alright, so I got it all hooked up. It's all ready to rock and roll. Got the new line all set up. Got water into it. Let's look at the truck real quick. There's a lot of, like, dirt and debris, especially up on top. You see all that lichen build up. Oh, stick. Awesome. You know, I got all this up here. It's all over the cab. You know, this takes years for this stuff to build up. And a hot water pressure washer is just what I need. All over the doors. It's not too bad on the sides, but hood. Yeah. See if we can put a little shine on this old beauty. Why am I not getting any water out of it? Alright, I'm trying to figure out why this thing won't put out pressure. I'm getting water, comes in, goes into the pump, and then it's coming out of the pump, and it goes into this unloader valve. And when I loosen the line that goes into the unloader valve, there's all the water pressure coming from the hose, because this thing's not running. So I'm getting water to the unloader valve. I even have this top cap off the unloader valve. And I don't know if that's a bleeder or not. I'm not sure what's going on. But we definitely have an issue here with the unloader, which is a good thing because it means I didn't do anything wrong with the pump that we know of yet. And I haven't touched this unloader. Literally left it where it was. We've kind of moved it around a little bit, just kind of working on things. And then when I take this line off here, this is basically after the coil. There's absolutely no water in it at all. No water has been in it, no drops. So that's fresh, meaning that we're not getting any water into the coil. And if we don't get water up into the coil and through, we're not going to get it out to our hose for the actual wand. I thought we had this thing figured out because it did put out water before, and now it doesn't. So that unloader has got an issue. I'm going to turn the water off, let some pressure off, and then see if I can figure out what's going on. All right, so I have this new unloader, but it is not the same. It is a bit different. I'm not sure what the differences are. It won't just bolt right up. So I got to digging into this a little bit, and right in this hole, there's a check ball that goes there. And that was, pretty sure that was seized in place. It wasn't like bad, and so I kind of cleaned off the rust on the ball itself and the seat inside. I don't know if that was the whole issue, but we're going to put it back together, and we're going to find out if it works. Should work. Because if that passage was blocked, water cannot flow. What does that passage do? There might be another check ball up there too. I think I see one. I'm going to pull that off right here, and there might be a check ball in there. If there's a couple of them, the one up here might be a bigger deal. Let me pull that apart. Well, it's not a check ball, but it is a moving part that could have gotten seized up. A little plunger there. I'll bet if that was stuck down, it would not allow. So this is the outlet that goes up to the coil. I'm going to clean it all up, and we're going to try it. All right, so I think I've got it figured out. So essentially this bypass valve slash, you can set the pressure, it has an easy start capability. What that means is when the pump is not building pressure and you literally just have the water pressure coming in from the hose, it will bypass over here and back down and recirculate back to the pump. Once it sees pressure, it sends and closes that check ball off and closes this whole side off, and then only sends pressure up to the top. So essentially, if you listen here, I'll blow real gently. You can hear it's coming out of here and here. Now if I blow hard, it'll stop coming out here and only there. You'll hear a thump. No air is coming out of here, it's only coming out of the outlet. This is where water's coming in, this is where water's going up to the coil and back out to the pressure washer hose. But I think that there was a valve here that was, or actually the ball here was stuck, and the actual check valve here was also stuck. All right, I got the water on. Whoop, there it is. Got me. That's what I'm looking for. Sure, I have rust all over my face because that water came out pretty rusty. I don't know if you can see it or not. So water has decided that it's too much pressure, so it is coming out of this overflow here for whatever reason. And then that little quick connect there, that connection is not sealed, so I gotta fix that. We're getting it out of the pump, and we're getting it out of the, maybe I can turn that pressure down here. Maybe it'll make a difference with this. Let's try it again. And this gun was not, it was just staying on, kind of like that. But now it kind of works. Okay, so either one, we're over pressure and that relief is doing its job, or two, it's not right and it's blowing too early. So I think I'm gonna pull this off and we're gonna take a look at it and see if it's dirty or clean, and then still have to deal with that. We are quite literally working our way through every part of this machine. So this thing says max pressure of 6,000 PSI is when it should release. That pump can't be making 6,000 PSI. It just can't. It is set to like 4,000 at best. All right, one more time. I'm trying it with a different wand. I don't think that's gonna make a big difference, but all right, I did a little washing, just kind of to get the taste of it. What I did to get this bypass to calm down was I had this thing cranked all the way pressure-wise. And so I backed it off like 10 turns and now it's not blowing off. So maybe this does have the ability to go past 6,000 PSI. I'd be surprised. Do I have a line blown? Oh yeah, it's leaking. Oh, right there, the hose just fell off. All right, so I gotta fix that. It's weird because you pull the trigger, there's a delay between when it engages and when you get full pressure. So it'll delay, wait like a second, half a second, and then you get pressure. And it's decent. It actually did not too bad of a job. I mean, I kind of did up here a little bit, and you can kind of see a line about right there, but it's all cold water. We got a few issues. Something's going on with, maybe it's that wand. Don't know. I really don't think so. Something might be up with the pump. The other thing is that the burner is not working. It's not working properly. It's not even engaging at all. Obviously, that is an issue. So I got to figure that out. The other problem we're having is this carburetor is leaking and it's not great. It's surging. So we definitely have a jet clogged in that carburetor. I have another carb. I was hoping to get away with not touching that carburetor. But as always, when you don't touch something, that's what needs work. And we've got a leak right here. So this little adapter that I made, I need to figure out how to get back to this fitting directly into the hose. Because if I can eliminate all this junk in the middle, then I have a better chance of not having an issue, not having a spot for leaks. I think I'm leaking right here at the thermostat. So yeah, we've got to dive into the engine. We got to dive into the burner and a few other things. But I think for now, for this video, I really wanted this to be one video and done. But we're going to need some more parts. We're going to need some more time spent. We got to dive into the motor, dive into the burner, dive into some of the bypass valves, possibly get a new unloader / regulator. We're getting there. This is a mountain of work beyond where we started. This machine was literally completely junk, but man, we have gone a long ways since I pulled this thing out of the weeds, and I am totally pumped. So, as always with these projects, they don't go as planned. And you know, it is literally like I almost have to touch every single thing on this hot water pressure washer to get it to operate right. There's almost nothing I really haven't been through. I think we're just gonna have to go all the way. So I hope you've enjoyed the process of digging this thing out of the weeds to where we've got it here. There will be a part 2 on this, and that will be the end of it. This machine will be used all the time because all of this old machinery that I buy, it all needs a good wash. It needs really more than a cold water pressure washer can do. And that's really the draw for me. I enjoy it. That's why I do it. I like finding these machines and bringing them back to life. Big shout out to MiTM for reaching out and basically helping me get this project finished. And so they are an awesome company. If you need a pressure washer, or they make compressors and other machines as well, reach out to them. Great company. All right, here's how it's gonna go. We got leaks somewhere. Now I'm getting literally no pressure on that gauge. Yeah, I definitely think our pump is bad. It's like 15 degrees out right now. But for me and my family, Maisie and I here, we'd like to thank you for watching Salvage Workshop, and I'll catch you on part 2.